Okay, hello. My name is Müller and I will talk about integrating immersive 3D worlds for teaching mechatronics. This presentation was not only prepared, and it was not only prepared by me, but also by some of my colleagues, and they did most of the implementation work. Well, most of you or part of you know me, and you probably know that all the time when I come to the REV conference, I'm talking about 3D and mixing virtual reality with real apps. That's our work and our passion. So I will talk a little bit about our new approach on this topic. Maybe you remember, or you have seen this already, and I presented it several years ago. This is actually the physical workbench of Presto, of pneumatics. And here you see a simulation of it. It's not an animation, it's simulation. And we developed this using CAD system and transformed it to VRML and used a browser with a plugin module to visualize it. And we coupled the physical workbench with an interface to the virtual. It worked quite well with some, of course, bugs and problems. But everything was done by hand, and we also couldn't use it in a distributed environment. We could use it via the internet, but we couldn't use it with several simultaneous users. So we went on to look for further ideas and further possibilities to merge the 3D web with real tangible lab tools, especially in our area mechatronics, where we have these physical devices, not only circuits, but also physical small machines and devices. And in the meantime, remember that a couple of years ago, the 3D web became popular with Second Life. Now it's going down, I think. But Second Life was a starting point of a new type of 3D web environments, and we tested different tools in this area, and our objective of our work this topic was to use these 3D web tools to establish a playful learning environment, to support team learning, and also to provide tools which are easier to model, to change, and to establish, and to try to integrate it in available lab structure, for example with these Festo models. And of course, in our teaching institution is also affected. Okay, let's talk a little bit about the combination of real lab and virtual lab. We all know that real labs are very important in engineering education. We cannot miss it, we cannot leave it behind. We need the real labs, but also the virtual lab, especially the simulation with virtual worlds, give us a lot of opportunities for experiments, for testing, for playing also with the system. And our idea was also to combine it in this kind of setting. The real manipulation of objects with all the advantages, and the advantages of 3D visualization and simulation. And if you have a mechatronic systems in mind and you want to combine it, you have to consider that you need to couple sensors and actuators and the model data of the system, of the graphical object or the virtual object, to have such a mixing of black and white. So in the end, it should be more a multi-model interface with real interaction and with interaction with virtual fields. That's more or less the concept behind it. If we have a closer look to this, especially 3D worlds, we have this principle. We have a virtual lab with all the simulated objects. We have the connection to the real lab here by an interface, a real physical interface, and we have to convert real world signal into virtual signal. For example, with this pneumatic circuit where you convert real air into virtual air. Okay, when we look for principal architecture of 3D tools, for example, Second Life, or we use in this development Open Simulator, which is a free tool, and it has a possibility to do that in a multi-user setting over the network. We have to provide, or we have to develop, well, this architecture. We have the server, we have here the clients with the browsers, which are already available, the server as well. Then we have to establish an interface where we exchange these signals and between sensors and actuators. And we have the interface to the real sensors and actuators. For example, these devices we have in the pneumatic circuit. Now, for the development tools we use, as I told you, Open Simulator. It's a 3D application server. It's a bit like Second Life, but it's free. You can change the source. It's a multi-platform, multi-user, and it's a very interesting tool. And I've recognized here that also other colleagues are using it. In Brazil, in Ireland, I suppose they tested it. There are several other tools in this area, for example, Wonderland or Open Wonderland. We tested several of these tools, but at the moment I think Open Simulator is quite suitable, quite an interesting tool for teaching and for enhancing it to couple it with real devices. And we use for the interface, we use this hardware. Maybe you know it is very easy to program, it's cheap, and here you see actually another Festo system. It's already also in the theory. It's quite similar, and it's a modular production system. And in our last approach with Open Simulator, we built models based on this system, and I show you a few examples that students did with Open Simulator. They built the virtual model of it and connected it to a real device. You see, this is well, it looks like a Lego world. It's very simple, but you can see the principle of, for example, this magazine here, there, with the changer module and so on. This is another example, students modeled in Open Simulator. they also used Blender to model the graphics and imported the 3D model in Open Simulator. Okay, I have a little bit to hurry. Here's another example. This is one module of this production system modeled in Open Simulator. This is the interface. Here you see only the results, not the technology which connects all the reality. I will talk about that in a few seconds. This is a complete production line, or several modules here, modeled in Open Simulator. This looks quite elaborated already. It comes very similar to the real device. And now the question, how can we couple, for example, these virtual assemblers and virtual actuators with a real controller? That's an interesting thing. So, if you retrieve that, you find several concepts. Also, the literature our colleagues from Northern Ireland has some experience with it. University here to test it, the link with reality, and you will find, for example, kind of remote procedure called based middleware you have to implement, or you implement a database-oriented middleware because all the objects of the virtual world are stored in a database. If you find a way to connect this database to a hardware interface with a driver and a special middleware software, you can establish, you can couple the virtual and the real objects. There are also some possibility to implement certain custom modules in the Open Simulator, but I will skip this. And if you want a very performant solution, you can modify the server. And that is what we did. We modified the server of Open Simulator as in open source. You can check to solve let's puzzles. So here are the different solutions already. I will skip this. Okay, we changed the server itself. And we have expanded in our paper in much more detail. What we actually did, we modified the event management, or we enhanced the management of the server main event loop. We included a few methods to link to the physical I/O difference. It's not a lot of coding. So if you find the right place, the right where you have to change it, it's quite easy.